In this video, I'm going to be explaining how to use the first derivative test to find intervals where a function is increasing or decreasing. And we can actually also determine what type of extrema is occurring. If I know that a function is changing from a positive slope to a negative slope, it must have been increasing and then changing to decreasing. We must have reached a maximum. Also, if my function is changing from a negative slope to a positive slope, it must have been decreasing and then changed to increasing. We must have reached a minimum at some point there. So not only can we tell intervals where a function increases or decreases, we can also tell what type of extrema it is without even having to look at the graph, just using this first derivative test. It is important to note, however, that it may be possible that at a critical point our function continues to increase, it just changes concavity, but we'll focus more on that when we talk about the second derivative test. So to use the first derivative test, we're going to follow these steps. Since we're talking about derivatives, we're going to find the derivative of a function first. Then we're going to find the critical values of that function, the derivative function, by finding zeros or values that make the derivative undefined. We're going to use those values to set up some test intervals, and we'll actually plug some numbers into the derivative function and evaluate it and see whether it's positive or negative, or in other words, increasing or decreasing. And then we can also use it to determine what type of extrema are occurring. So let's do an example. Here we're given this function. We're going to find intervals on which the function is increasing or decreasing, and also describe what type of extrema is occurring. So first step is find the derivative of the function. The derivative of that function is 3x squared minus 3x. We're going to set it equal to 0 and find a critical value. There are no values that make this function undefined, so we're just focused on the zeros. We could factor to find the zeros, so factor out of 3x, and we can find our solutions here are 0 and 1. So now use those values to set up some test intervals. I'm going to set up an interval that goes from negative infinity up to 0. And then I'm going to set up an interval in between my zeros here. So an interval from 0 to 1. And then I'm going to set up one last interval that tests everything after my last 0, so from 1 to positive infinity. We're going to plug values in that are within these intervals, and we're going to plug them into our derivative and figure out whether they're positive or negative values. So test a value that's on this interval. Negative 1 would be the easiest. So if I plug negative 1 into my derivative function, I can determine whether it's a positive or negative value. And you can plug those values into either form of your derivative, the factored form or the unfactored form. If I plug negative 1 in here, I got negative 1 minus 1, which is negative. And if I plug negative 1 in here, I also have a negative. So a negative times a negative gives me a positive value. So I know that all of the values on this interval have a positive derivative or a positive slope, so I know they're going to be increasing on that interval. Let's test this in between interval. A value that's in between 0 and 1. Well, 1/2 would make the most sense. I could plug 1/2 into my derivative, figure out whether it's positive or negative. If I plug 1/2 in here, I get 1/2 minus 1, which is negative, and then plug 1/2 in here, which is positive, and a positive times a negative gives me a negative value. So I know that my function is decreasing on the interval from 0 to 1. Last interval we need to check. Plug in a value that's on this interval. A value of 2 would be the easiest. So if I plug 2 into my derivative function, what do I get? Well, 2 minus 1 is positive, and 3 times 2 is positive. Positive times a positive gives me a positive value. So I know that my function is increasing on that last interval. So describe the intervals in which we're increasing and decreasing. Well, the function is increasing on the interval from negative infinity to 0, and on the interval from 1 to positive infinity, and it's decreasing on the in-between interval from 0 to 1. We can also describe the types of extrema that are occurring. Since my function is increasing and then decreasing, and it's changing right at x equals 0, I know that I went up and then came back down. I must have a maximum at x equals 0. And then over here, I also have a change in my slope. I went from a negative to a positive. I went from decreasing to increasing, so I must have a relative minimum at x equals 1. We can verify that by looking at the graph of the original function. we can see that we do have a relative maximum happening at 0, and we have an increasing function from negative infinity up to that point. We have a relative minimum occurring at x equals 1. My function was decreasing in between 0 and 1, and then it went back to increasing from 1 to positive infinity. We can do it with more complicated functions. Just go through the same steps. I want to let you pause the video and kind of work through this on your own. We start with this original function. We use the quotient rule to get the derivative, and we end up with our final derivative here, or we could factor the top. There are no values that will make the bottom 0 or undefined, because there's no value I could plug in here to cancel my positive 1. Even if I plug in a negative value and I square it, it becomes positive. So no values are going to make this function undefined. We just got to worry about zeros of the function. So we're just worried about zeros of the numerator. We can factor and find the zeros. We could set up our intervals based on the solutions positive and negative 1. So negative infinity to negative 1, negative 1 to positive 1, and then from 1 to positive infinity. And we can test values that are on those intervals. So a test value on this interval, negative 2 would be the easiest. Plug it into either form, the factored form or the unfactored form. If I plug in negative 2, then negative 2 squared is 4. 4 minus 1 is 3, and 3 times negative 2 is negative. So I know that everywhere on this interval I'm going to have a decreasing function. Plugging in a value in between negative 1 and 1, 0 would be the easiest. If I plug 0 in, 0 minus 1 is negative, and negative times a negative is positive. So I know I have an increasing function on that interval. And if I test the last interval, if I plug a value in that is within that interval, 2 would be the easiest. If I plug 2 in, I get 2 times 2, which is 4. 4 minus 1 is positive, and then a positive times a negative gives me a negative value. So I know that my function is decreasing on that interval. So we could describe where our function was decreasing and increasing. I could state what type of extrema are occurring. I went from a negative slope to a positive slope here at x equals negative 1, so I must have a minimum occurring at x equals negative 1. Right here at x equals 1, I changed from a positive slope to a negative slope. I must have a relative maximum. And we can also verify that we were decreasing from negative infinity to negative 1, increasing from negative 1 to positive 1, and decreasing from 1 to positive infinity. One more example, we'll do a trig example. So given this function on this interval, first step, find the derivative. Simplify, we get 2 times the sine of x. Find the zeros. There are no values that make this undefined, so we're just finding the zeros. And the values that make sine function 0 would be 0 and pi. And since we're looking at this interval right here, we also need to include negative pi. But because negative pi and pi are on our endpoints, we actually don't really need to include those in our test values. We're just trying to look at 0. But we can set up our intervals. We know that our interval started at negative pi, went to our first 0 at x equals 0, and then went to our right endpoint on our interval, positive pi. And then we can set up 2 intervals to test. A value that's in between negative pi and 0, for example, would be negative pi over 2. So if I plug negative pi over 2 into my derivative function, I can determine whether it's positive or negative. The sine value of negative pi over 2 is negative 1. And so I know that my function is decreasing because I have a negative slope on that interval. One more interval to test. Some number that's in between 0 and pi, well, positive pi over 2 is on that interval. I could plug that in. The sine of pi over 2 is positive 1. So I know that my value is positive. My function must be increasing on that interval. So we can state the values of the intervals on which we're decreasing and increasing, and we can verify it looking at a graph. I know that at x equals 0, I changed from a negative slope to a positive slope. I must have reached a minimum, and we can see that on the graph. My function was decreasing from negative pi to 0 and increasing from 0 to pi. So there's an introduction to the first derivative test.